And now we power on to 4.7, solar radiation, again, and Earth's seasons. So our goal here is to explain how the sun's energy affects the Earth's surface. So to accomplish this goal, we will describe the amount of solar radiation received at different parts of Earth and explain the relationship between the latitude and the tilt of Earth's axis and the seasons. So we've mentioned the term insolation. Here's that incoming solar radiation. Changes depending on the season and the latitude that you're found at. So we've got a couple different points here. We've got 0 degrees, basically our equator right here. Not basically, is the equator. We've got 30 degrees north. Remember, this is our dry air, typically desert area. We've got 60 degrees north, right here. And last, we've got 90 degrees north, which would be the North Pole. So we can see that as the months change, January, February, March, April, our amount of solar radiation is different. First, just because of the latitude. So in January and February, our people at the North Pole don't even get any incoming solar radiation because they're in 24 hours of darkness. And as you move closer to the equator, you get more insolation. And it increases as we reach the March equinox. Now, as we change seasons, we see that we've got, at least for, except for the equator, we've got less insolation here. We increase when we get into spring. We peak on the longest day of the year, which is the summer solstice, June 21st. And then we mirror that and we start to decrease till we get to the September equinox, which is what we just passed. And then until we get to our lowest point, which is December 21st, the shortest day of the year, and then it repeats. So we see that the people living in around the North Pole go from 24 hours of darkness to quickly lengthening days to 24 hours of daylight, and then back again. But notice that their amount of direct insolation is very short and more than you get at the poles, but for a very short amount of time. So here is that angle of insolation. As we mentioned in the video on global winds, the equator here and areas close to the equator get much more concentrated amounts of solar radiation versus up here in more northern America, where we get a more oblique angle. So the seasons also impact the total number of hours of daylight that you can get. So it's not just that angle, it's also how we're tilted. So let's start with the June solstice. So this is our longest day of the year. And you can see right here in North America, this Earth is tilted in the direction of the sun. So we're getting the most direct sunlight. So it's direct and it's happening for longer. As we start to spin towards September, now we're over here. We're going to get less, but still a good amount, which is going to match what you also see in March. But however, when we get to December, you see that now we're pointing away from the sun. So this is why we are in winter here, is because the tilt of Earth has us tilted away. So it's a common misconception that during the summer the Earth is closer and therefore warmer, but in reality we're actually closer in January, which is when we're pretty much at our coldest point. So to summarize, we can explain how the Earth's energy affects the Earth's surface, that the equator receives the most direct and intense sunlight, the poles receive the most indirect sunlight, and that it's the tilt of the Earth, not the distance of the sun and the Earth, that determines our season.